Recording. Hi, everybody. Happy Thursday. Talking about working at Walmart and alternative side hustles involving latent variable models, much more financially prudent. But Nathan helped track down the option that I was missing in my Lavon code for this unit. It is possible to override the default of listwise deletion and replace it with pairwise deletion, which is what M Plus does, as near as I can tell after rereading their documentation too. So yesterday morning, I updated the online files that go with example 5 to include that option, and I reran the models on my data so that you could see the results match closely but not perfectly with M+. Of course, it has to be off in the second decimal place, just enough to tweak me and the homework system, but it's much better than what it was. The other option that I think Solomon had sent me was with respect to changing the estimator, and that is still not a thing. So when Lavon was built, they left a spot for it in case they wanted to do binary and ordinal response models using full information maximum likelihood. There are, like, if you go through the documentation, that's one of the choices. If you actually try to turn it on, it's like, yeah, no, we don't do that yet. So had I been able to switch my estimator, then the method of missing data addressing would have been different too, but that's not a thing in Lavon, whereas it is in M+. So some progress, but not all of the way in terms of trying to get the packages to converge onto the same set of estimates. So I do have a caveat to example 5. Let me get the screen share going for everybody here. That I added.
For your next, you should ask Jonathan to develop a full information like the estimated for binary data for.
Why don't you do that? You do that. Because, every time I complain about R, he's like, why don't you write your own package? And I'm like, why don't you just let me complain to you? And like, this is the part where you listen and nod, not the part where you try to tell me to solve my own problem, right? So you can do that. Yeah. It's important when you're complaining to someone are they trying to help you, or are they just trying to let you vent? And that's the question. So I'm usually venting. But I don't have the skills to fix any of this. He might, but he has to decide if it's worth the effort. He's working on a package actually that's blatant is the name of it. It's latent with the B in front of it. So it's supposed to do psychometric models using Bayesian estimation, and I imagine that everything that this is somehow nested in that with a certain combinations of priors and constraints. So he may already have that. You'll have to ask him tomorrow. But what I was going to say is that I updated the caveat that was on the front page of this example to say now I have pairwise deletion, the files are updated online. I still don't have Lavon in this handout though, because it doesn't do full information maximum likelihood for these items. And that's the first set of models and the link function in Logits that we're looking at. So that's the reason why they're not in the front part. I will mention where Lavon does have comparable results when we get to that section of the handout. So this is where we were last time. Do you remember the story behind these data? Starting to look at actual numbers. Am I frozen already? No? Okay. So do you remember the story? Or should I talk about the story again? These are real data. These are real older adults who were ages 80 to 100, answering 7 questions about their ability to live independently and complete tasks that vary in physical difficulty predominantly, as well as a little bit of mental stuff here. So the items that we had in this example: doing housework, making your bed, cooking, everyday shopping, getting to places outside of walking distance. So that would be like taking public transportation. Handling banking and other sorts of business, so a little bit of mental stuff there, probably in addition to just organizing your files and things, and using the telephone, which was the easiest item. Most people could do that. So we're looking at binary data, and we are summarizing the relationships among these items with a different flavor of correlation. So the idea that Pearson correlation is going to be limited for binary data. The maximum correlation that any 2 binary items can have is going to be far below 1 to the extent that the items have a mean different than 0.5. So anytime there's any asymmetry in the proportion of ones and zeros, the correlation between those two binary items is necessarily going to be less than 1. So we see quite a bit of difference between what the estimated tetraquark correlations are and Pearson correlations. And tetraquarks, do we need to talk about that again? Would that be good?
Could you run through that?
Mm-hmm. So this is one of those where it's like my knowledge gets me up to a certain point and then I hit my head in reading the documentation and can't get much further than that. My problem, of course, is that I was a psychology major and no one pulled me aside and said, hey, psych majors need math too. Had they pulled me aside and told me that, I would have taken undergraduate courses in math, but because I didn't think I needed it, I only took intro calculus and that was the end of my math. So I have difficulty, honestly, in reading technical documentation that has a lot of very dense mathematical notation because it's an unfamiliar language to me. So I hit a point where I can understand conceptually, but then everything gets a little fuzzy. So my understanding of this idea is that a tetraquark correlation is using the proportion of responses in each combination of 1 and 0 and using a bivariate normal distribution given those proportions to figure out what the underlying correlation would had to have been to create that proportion of people in each section of the scatter plot. So we talked about this last time in terms of extreme cases. If two variables are unrelated and we were to make a scatter plot of them, so let's just pretend they're continuous for right now, what would that scatter plot look like for two variables that are unrelated? Random. Yeah, a ball. Yeah, it would not have a pattern. It would just be like a circle of points or something. And if the two variables were perfectly correlated, then what would you see in the scatter plot? Yeah, a line, either positive or negative, depending on your thing. So to the extent that you have participants in the off cells, so in this example, it would be cell B and cell C, where they got one right, they got the other wrong, then that means that the correlation is not perfect. Because otherwise you'd expect it to be everybody who got a 0 and 1 got a 0 on the other, everybody who got 1 on 1 got a 1 on the other. And so then the question is, what should the correlation be that gave rise to the number of people in the C and B cells instead of A and D? So it tries to estimate this correlation. It's not a calculate thing, it's an estimate thing. And that means that reasonably differently programmed software packages could potentially come up with different answers, in particular with how they handle empty cells. So the bottom of this box of correlations here, I have the contingency table of responses to questions 4 and 7. There is nobody who said that they could go shopping. They got a 1 on question 4, but who said that they can't answer the phone? They got a 0 on question 7. And that makes sense because answering the phone is easier than going shopping. So answering the phone is nested within item 4, essentially, which means there's a blank cell. And we need all 4 cells to be able to compute what the tetraquark correlation would be. So what M plus does is add a tiny, tiny number to it so that it's no longer blank. It means that the correlation itself, though, is relatively unstable. So the standard error for that correlation is 0.17, whereas all of the other standard errors for the tetraquark correlations are much, much smaller. So the standard errors can help to clue you in as to how good of an estimate each of these tetraquark correlations is, and that's going to be relevant downstream because the alternative to full information maximum likelihood is to start with these tetraquark correlations and estimate your CFA model parameters on those instead. So one of the ways that in that type of estimation, there's differences in weighting in terms of which correlations are prioritized to be recreated. And the ones that are a little bit, not sure what it should be, get a lower weight in how the model reproduces each of those covariances. So that's why this matters. I think just from the purposes of starting with descriptive statistics, the same idea of stare at a Pearson correlation matrix and see if your items are related. Because if your items are not correlated, what does that imply for your factor model? if your items are not related in the first place.
The factor is 0 or just doesn't exist.
Yeah, you don't have a factor. The job of the factor is to recreate the relationships between your items. If there are no relationships worth recreating, there's nothing for the factor to do. So you could end up with a really well-fitting model of a bunch of non-significant loadings because the relationship between the item and the factor is near 0. So from a troubleshooting point of view, just staring at this correlation matrix is a useful thing. Staring at the Pearson correlation matrix for binary items could potentially lead you astray because it might look like things are unrelated, particularly for items that have a very skewed distribution where there's a lot more zeros or ones, or vice versa. So all systems look good with respect to these tetrachorics. It does look like item 7 has lower relationships with item 1 and with item 5. That is likely a function of the fact that it's the most easiest item. And so it limits the extent to which it can show covariance with these other items because it doesn't have that much variance in the first place. Doesn't mean that it's a bad item though. So normally in CFA, see, normally that's a pun because like CFA is for normal outcomes. See, normally in CFA, we would say that any item that looks like it's not that correlated with the others is potentially a bad item. But I wouldn't say that here. So item 7 is a bad item from the perspective of not having a lot of variability, but it's a really good item from the perspective of measuring people who are of very low ability. Because this is something that like anybody should be able to say yes to if they're at least at a certain amount of theta. And if you say no to this, that's somebody who has real issues. So that can help measure people of lower ability in a more specific way than what the other items can do. Okay. How is that for a review thus far? Good so far? So we looked at code last time. By the way, I have heard from several of you that M+ on the virtual desktop is cooperating sometimes and not others. Unfortunately, I still don't know why this is. I ran into this problem 2 years ago. I tried to help students troubleshoot it. Some of you have error messages that say that your path has exceeded 255 characters, even when the length of your path is the same as another model that ran fine. I don't know why the error shows up sometimes and not others, but there are a few things that you can do to help if you are running into this problem. One is to shut off any of these additional options that generate extraneous files, like the save data and the plots. Shut those off until you need them, and sometimes that's enough to at least get a model to print the output for you so that you can see if it's a model worth investigating further. You can also move your files from wherever they're stored on your local machine to the university's H Drive server because that drive is native to the virtual desktop platform. It understands where it is. And if the path to your file is shorter, it may stay within the 255 character limit that we're running into. Because it's not just your path, it's also tacks on the path to where the M+ program is installed. So that's where the extra characters are coming in. If those things don't work, let me try to help you. If it comes to it, you can send me your data and I'll run it myself. Like, if we hit at that point. You can also try to use Levon. Mm-hmm.
I actually ran into that issue, and I found I don't know if this will work for anyone else, but I ended up, because the end of the line is marked by the semicolon, so
Mm-hmm.
like, I just pressed enter and then just moved the really long string to another line and did that a few times and just broke it up.
Mm-hmm.
And if you do that for like for a file path, I would just do it after one of the backslashes. Another thing too is, if firewalls are getting in the way, I know I had an issue because my computer thought that it was a malicious program trying to access my local files. So turning off the firewall might also, or temporarily deactivating it for a little while might help.
Yeah, when you connect to the Citrus thing, it asks you what level of permission that you want to give it. And so you may want to reinstall Citrix and make sure that you've allowed it like read and write access to all of your directories, because that's been another thing that folks have found. In the chat, looks like virtual desktop has been giving me trouble, lots of random disconnection. Oh, that's fun. I'm sorry about that. At least you don't have to pay for M+. Like, that's the alternative. You can cough up the student license fee, which is a few $100s. The good news is that M+ is what I'm using because to me it is the most flexible, it has the most capabilities, but you don't necessarily need all of those capabilities. So if you're a Stata user who can figure out, you know, the SEM package in Stata, you can use that for your CFA if you need to. You can use Lavon, Procalus and SAS. I'm trying to think of other ones. There's a number of packages that will do CFA. It's only in certain circumstances, such as these ordinal data, where you start running into what one can do and the other can't. But yes, if you're running into these kinds of things where M+ is just not cooperating, please let me help you, because I did not intend for that to be a dimension of difficulty in this assignment. That was not my intent. So yeah, send me your stuff if you can't get it to work, or otherwise we'll set up a time where I can Zoom with you. Moving the files to a closer to the root and to the H drive would be the thing I would try first, though. So anybody else have things along those lines they want to bring up? Okay, so yes, these parts that are doing extra work, shut those off, and that may also help. So the things that make this code different than your typical CFA model, there's basically three. Categorical, that's the magical outcome. So what happens, do you think, if you forget this option under the variable command? What do you think you would get if you didn't tell it that these are categorical? I'll give you a hint. We haven't said it was categorical up to this point in the class.
Would it be nominal?
Not nominal, just interval. So it would pretend that these are interval outcomes, continuous, normally distributed. That's what it defaults to if you don't tell it this. So the categorical option within M+, within Lavon, it's the ordered option within the call to Lavon, does the same thing. And the nice part about it is that it figures out how many categories each variable has and builds the model accordingly. You don't have to say, you know, item 1 has 2 categories and item 3 has 5 categories. It will know that. So that's one. Under the analysis, so this is the part that is not replicated in Lavon. Full information maximum likelihood in using a logit link is what I have asked for. We haven't talked about estimation yet because I wanted to get some numbers in your head in terms of what this stuff means, but that's coming on Tuesday of next week, I think, if not today. This one is the extra piece that the people who make M+ told me to try and get the converging results across platforms, given the way that they do their numeric precision. And the other new piece, zooming in so that we can see a little bit better, the $sign. So in brackets, we used to just list the name of the variable, and that referred to either its mean or its conditional intercept. Now, instead of intercepts, we have thresholds. So what is the difference between an intercept and a threshold? Yeah, -1. Yep. Intercept times -1 equals threshold. Threshold times -1 equals intercept. So functionally speaking, what it's going to tell you is, rather than saying what is the probability of a 1 when all the predictors are 0, it's what is the probability of a 0 instead. To turn it into an intercept, multiply it by -1. Otherwise, this code looks a lot like your standard CFA code. The first line is requesting that all of my factor loadings are estimated. And yes, in this case, you need a star. The star overrides the default that the first item's loading is automatically fixed to 1. That is a default. Putting the star at the end of the sequence like this overrides that default and turns all of the rest of the loadings into free parameters. If you forget it, the first loading will be fixed to 1 instead, which I don't want because I have fixed the factor variance to 1 instead, as well as the factor mean, which then allows me to estimate all of the item thresholds as my location parameter. So it's the same logic in terms of identification as in CFA. You either fix one of the loadings to 1 or the factor variance to 1. On the mean side, you either fix the factor mean to 0 or you fix one of the thresholds to 0. Same thing. And over here, there we go, that right there turns this same 2PL model, as it used to be called, into a 1PL model, where the word loading acts as both a label and a constraint. So the fact that I've given one label to what is going to become 7 different loadings means I'm saying, hey, make them all the same and tell me what happens. So that is otherwise known as a Roche model. It's an assumption that all of the items are equally discriminating, such that you can make their slopes all the same and everything would fit just as well. Okay, questions on code or setup? So last time we looked at the model fit information, what limited amount of fit that we have. And so while we have our HO value, which is the height of the data under the model that you fit, remember you are the hoe, we don't have its friendly neighbor, the H1. It's not here and it can't be here. The H1 model is if we let every mean, variance, and covariance be whatever it wants. That's what it was in CFA. In categorical data though, you need more information besides means, variances, and covariances. What the saturated model would be, given full information maximum likelihood, is the contingency table of all possible responses. So given 7 items, it's a 7-way table of zeros and ones. And that would be the answer key that it's fit to. And it's not possible in a lot of cases, such as this one, to actually do that because you're missing some cells. So for instance, there's an error message over here. Of the 630 cells, we're missing 1, got deleted. So that means that whatever chi-square we would do to compare our contingency table of responses with the right answer is not going to be valid. So the area of model fit in IRT land, that's why they've come up with all kinds of other things, because there is no easy way. There is no easy saturated model in IRT land. The easier ways people have come up with rely on tetrachoric correlations as a summary of what the model predicts, even if the parameters are estimated by maximum likelihood. We'll talk a little bit about that in the slides when we talk about estimation. So we don't have anything related to traditional measures of fit. We don't have a null model. We don't have a saturated model. That means we don't have RMSEA, SR, CFI, TLI, any of that. It's all gone. So right now we don't really have a sense as to whether this model fits at all. What we can tell is, given the difference in log likelihood between the 2-parameter model and the 1-parameter model, we can do a likelihood ratio test, which is what we looked at last time, and figured out that the difference in -2 log likelihood was significant. So I would either say that as it hurts the model significantly to constrain all the loadings to be the same. It hurts to say that the items are equally discriminating. Or I would say if I start with the assumption that they're all the same and I add extra loadings, that makes the model better. Either of those is correct. It's just it's a question of what is the point of the test and what is the information you're trying to convey. Degrees of freedom. So the 2PL model spent 14 parameters. Hey, stop that. Where'd the 14 come from? What are we counting? 7?
7 B parameters and 7 A parameters?
7 B's and 7 A's, or in the way that it's native to M+, 7 slopes and 7 thresholds. But we can get from a threshold to a B, and we can get from a slope to an A. So yes, I will take that as correct. What about the error variances? What happened to those? Do we have any of those?
No.
No. And what are we just assuming that the variance would be of the pretend continuous variable that underlies each of these binary responses?
0.
No, we have a different pretend number. It's from the logistic distribution because we're using a logit link function.
3.29.
Yep, it's pi squared over 3 to be specific, but it works out to be 3.29. So in the Excel sheet that goes with this example, I have cells that show you how to calculate, say, standardized model parameters, where you would need to know what the total variance of each item is. 3.29 is fit in as what the residual variance would be. So 3.29 is the residual variance of all of these items. It's not a number that we need to do anything about. It's not separately estimated. And over here, the one parameter model instead has only 8 parameters because we dropped 6 of the loadings. So we would have 7 locations implemented as thresholds in M+, but we can get from there to difficulties and 1 slope instead of 7. Slopes and A's are the same in this case. All right, so then we got to the numbers, and that's where we left off, I believe, because there's 3 different sets of numbers here that we want to make sure that you know what to do with. All right, questions or any of that you want to hear again or differently? Ready to do this? This is the fun part, learning what the numbers mean, right? So this is where you become not dangerous. Like anyone can type the M+ code or borrow one of the examples and make the numbers show up, but to know what to do with the numbers, that's the transition part here. And it's more complicated in these models because you got to figure out which version of the model you're talking about. So first off, the default output that comes first here, unstandardized model results is what it's called. And I have here in parentheses, IFA model solution. So this is what people would call an item factor analysis because it is phrased as loadings and then either intercepts or thresholds. We get thresholds in M+. So the loadings then are the first thing here. These are slopes. The slope is always the change in y for a 1 unit change in x. Right? That's a slope. So then if I replace the relevant words here, change in y means the change in the logit, so the change in the log of the odds of the probability of a 1, that's what we're predicting on the left-hand side of the equals, per unit change in x. X is theta. Theta has a scale in which the mean is 0 and the variance is 1 because that's what we set it as. We nailed that down. So each of these loadings says what is the change in the logit of that item's response per standard deviation increase in theta. That's what 1 unit is in the scaling. So according to this, if I just eyeball these numbers, which item is the most discriminating? Four. Yeah, which is the least discriminating? Yeah, number 7. Now, does that mean that I could maybe get rid of 7? Like if I wanted to make a shorter form, since it's the least discriminating? Or should I think about something else first? Is this a bad item for everybody? ICC and reliability, yeah. Keep talking, or keep typing, as it were. What do I need to think about? Information, yeah. For whom is this a bad item? And do I have any other kinds of items that I could use for those kinds of people instead? That's the question. Item 7 was the easiest one. So part of the reason why it's the lowest in discrimination is likely because it's the easiest, and there's not a lot of people with which to estimate this slope, because most of the people could do this item, 94% of the sample. So it's these loadings tell you how discriminating each item is at its B difficulty location. At the theta level at which the probability of a 1 is 50-50, this is how discriminating it is in logits. So for these, more is better. What would happen if one of these is negative? Can you have a negative discrimination or loading? Could that happen? Could it or should it? Two different questions. My question is, could it? It could, and I've seen it happen. Yes. But should not is correct. Yeah, could happen. A negative loading would mean that as theta goes up, your probability of a correct response goes down. That means it's working backwards. That's a bad item. That type of item would have probably been found out as a negative or very small item remainder correlation with the total. Probably would have seen that happen at that level. That for the negative items, I don't know what that means.
Yeah, like the items that we listed in example for positive and negative items. So
Oh,
yeah.
Yes. So here's the thing. In theory, you could leave your items that are positively worded and your items that are negatively worded as is and fit them to the model. And then in that case, some of the loadings should go backwards. They should be negative if the item is coded such that higher is worse. But in practice, doing that is going to cause estimation problems because then the model doesn't know which way is up. Because you would have a solution where like the positive word items have positive loadings and negative have negative, and that would fit equally well as the reverse, which would just mean that theta is worse is higher instead of worse is lower. So to keep it so that we know which way theta goes in terms of whether it should predict a higher response or a lower response, we try to keep it consistent. So you'd either want to code it so that all of the items are measured that more is worse, in which case you might call your theta something like disability instead of ability, like if more is worse, or sickness, or some other kind of word that conveys that more is bad. Whereas in this direction, it's ability, because a higher theta means a greater probability of being able to do these things. And yes, I would code it in the way that you want to talk about it. Some traits naturally lend themselves to more is better, and some traits lend themselves to more is worse. And I would code it in the way that you want to talk about it. Is a negative loading indicating bad items for SEM? Yep, that is for across the board. A negative loading is not good. It means it's going backwards in the way that you thought. So whether you're in CFA, IRT, IFA, or any of the other types of link functions that you might have. Okay, now the tricky one, a threshold. The threshold is the opposite of an intercept. These are location parameters, but they do not tell you the same thing as a B difficulty location does. What these tell you is what is expected for the average person. Because intercepts and thresholds are both conditional on factor score equals 0. So they're an expected response of some kind when factor score is 0. The difference is, are they the expected response of a 0 answer or the expected response of a 1 answer? Thresholds are the expected response of a 0 answer. Intercepts are the expected response of a 1 answer. So which of these is the easiest item? And we already answered this question just from the proportion of people who got it right, and that's still the case. Yeah, item 7 is the easiest. It is the smallest number in this list of negative values. So for item 7, the threshold is about -6. So -6 is the logit of the probability of getting a 0 for answering the phone for somebody of average ability. What does a logit of -6 work out to be in probability? I don't know the right number, but I know the answer is tiny, tiny number. That's the answer. And a logit of -6 is really close to 0. So basically, if you have somebody who has average ability as calibrated by this scale, there's no chance that they're going to get this wrong, that they can't answer the phone. The probability of getting a 0 conditional on a theta of 0 is what a threshold tells you. And in the direction of thresholds, a smaller threshold is an easier item, a larger threshold is a more difficult item, so it does correspond to the right direction of difficulty. What's the hardest item? What's the most difficult item to do? Yep, item 1, yep, followed by item 5. So for somebody of average ability, the logit of them not being able to do item 1 is -1.6. So still well under 50-50. What is the logit of them being able to do the item instead? Yeah, times -1. And if I want to talk about being able to do the item instead, that's an intercept. A threshold is not being able to do the item. Okay, how are we doing? So if you're okay with loadings, which most of us are at this point because they're slopes, and you're like, what the hell is a threshold? Just multiply all these numbers by -1 and turn them into intercepts. Then you're good. Then it's the intercept slope form of the model. Intercepts are backwards in terms of difficulty, but they're easier to interpret. So thresholds then give us the expected y when x is 0. The IRT version of the same model over here gives us the x at y equals 0. So location parameters are tied to something being 0. The question is what? Thresholds and intercepts tell you what y is when x is 0. Difficulties tell you what x needs to be to get to y equals 0. How much ability do you need to have a 50-50 shot at doing this item? So the conversion into difficulties, let me remind you where the formula is. So here's a plot that has the ICC for item 1. This is slide 63. So the item 1 slope is 4.3 at the point of difficulty. What we just looked at are the parameters given by the red line here. So the red line gives us the location on y that corresponds to a theta of 0 on x. We're moving over from the red line to the blue line to talk about difficulty. Difficulty anchors on y equals 0, probability of 50-50, and difficulty tells you how much x you need to have a y of 0. And the conversion between the two is right here. A threshold is the same thing as A times B. A loading in this case is the same thing as A because the factor variance is 1. And the other conversion formulas given our parameterization are on slide 60. If it will let me go to that. My computer is overwhelmed with IRT as well. There they are. It's like, I don't want to do this anymore. This is too hard. You're not wrong. That's why I'm saying the same thing over and over again, slowly with my eyes shut, because it takes all of my processing to say it correctly each time. So like if you could hear like the fan of my brain spinning uncontrollably to try and like cool my brain down, that's what it sounds like in my head. So B is threshold divided by loading. Threshold is A times B. A is loading times the variance of theta. So loadings and A's are going to be the same if theta has a variance of 1. So all things being equal, I like B's better. I just do. So for item 7, how much theta does it take to have a 50-50 shot at answering the phone? Yeah, negative 1.8. How would I describe a person with a theta of minus 1.8?
Would it be a person with an ability that is 1.8 standard deviations below the mean?
Yeah, low.
But I guess it would have to depend if you scale it that way.
Yep, that's how we've scaled it. So yes, that you have to know what the scale of theta is to answer that question. And I know that the scale of theta has a mean of 0 and a standard deviation of 1 because that's what I told it to do. And so this person is about 2 standard deviations below the mean. That kind of person has a probability of 0.5 of being able to answer the phone. So rather than talking about what is the expected value for an average person, that's intercepts and thresholds, difficulties say how much theta do you need to have a 50-50 shot? Who is this item most useful for? Is their difficulty level. So we decided which item was the hardest before. Item 1, right? So how much theta do I need to be able to have a 50-50 shot at answering item 1? Minus 0.3. So somebody just below average would have a 50-50 shot at answering item 1 correctly, being able to do this task, which I don't remember what it is anymore, but something not that challenging. Okay, standardized solution is also down here for the loadings and thresholds. You can interpret the standardized loadings in the same way that we did in CFA, but with the caveat, it's like for whom? It's that loading really only holds at the corresponding difficulty level. So we tend not to make as much of a deal out of those. All right, here's a question. Do you think it makes sense to compute an omega to indicate the reliability of the set of items? This is a question that reasonable people disagree about, by the way. Question is, omega, remember that was sum score reliability in CFA? It was a function of factor loadings, error variances, and any error covariances. Does that make sense here? The fact that I don't have one is sort of a giveaway of where I'm going with this. I don't think it does. Jonathan also doesn't think it does. Here's why. The idea of an omega is that reliability is constant. It comes from the idea of CFA, where there's a linear relationship between theta and the item response. So a good item is equally good all the way across the theta continuum. It never shuts off. That's not true. It's probably not true in CFA either, but we pretend. But in this case, it has to shut off. It has to stop at a probability of 0 or 1. So the idea that there's a constant amount of reliability, like I could compute an omega and say, omega is 0.7, yay me, that doesn't make sense. It's inconsistent with the idea that each of these items has a slope that's only operational for some part of the theta distribution. So I would not use the loadings to compute omega. I would do something else, which is information. Okay, no problem with people who have to leave early. So let me foreshadow what our information function is going to look like with this. Do you notice anything in common about the range of difficulty covered by my 7 items? Because these are the amounts of theta. Item difficulty is the amount of theta needed for a 50-50 probability, and all these numbers are negative. So all of these items are going to be most useful for people who have below average ability. What about people who are above average? We don't really have any information about them. So the fact that our difficulties only cover half the range of theta at best is going to translate into reliability that tanks after 0. There's going to be a whole lot of people who say they can do everything. On the bottom of the slide here, I have the numbers inserted into the formulas so you can see how this would translate. So an IFA model, for instance, the equation for an IFA model is -1 times the threshold, that turns it back into an intercept, plus the loading times theta. So I have the results of what the predicted logit would be for item 1 and item 7. Notice the minus signs are gone because of the minus in the equation that takes it out. And so a logit then that's implied by this model translates into a probability. So for item 1, for instance, we would have, if theta is 0, the expected probability of doing it is 0.84. For item 7, an average person has a probability of doing it of 0.997, so 0.003 for not doing it. If I use the IRT parameters instead, then I have the same A parameter, that's the loading, sitting out front as the multiplier. Theta's inside the parentheses, and then it's minus the difficulty value, which are all negative. And if I work out the math this way instead, lo and behold, I get the exact same probabilities. So you either need a threshold, an intercept, or a difficulty. You can get back and forth across the 3 given 1. You either need an A or a loading, and they will be the same number if theta variance is 1. They'll be off by a function of the square root of theta variance if not. It's 2 different ways of phrasing the model to create a predicted probability for each type of respondent conditional on theta and conditional on the item parameters. So this difference is, the word that I use for this is parameterization. These are 2 different parameterizations of the same model. You can either have A's and B's, in which case you'd call it IRT, or you'd have loadings and then either a threshold or an intercept, in which case you'd call it IFA, but you can go back and forth. All right, how are we doing? We like numbers? Do you know what's even better than numbers? Pictures. Yes. Anyone who needs to leave early, no worries. I won't take it personally. How's that sound? Here's some pictures. So these pictures, the way that I made them is to output information that was an M+, send it over into Excel so that I could make prettier pictures. So inside the example 5 Excel file that goes with this example, I have instructions on how I got the pictures out of M+. So which combination of drop-down menus, because there's no code that does it, unfortunately. But these are the item characteristic curves for my 7 items. So these describe the relationship that is nonlinear because the y-axis is probability, and these are the slopes that necessarily shut off as they get close to 0 or 1. So item 7 is this item right here, which we said was easiest, and we can tell that from the picture because it's furthest to the left. And its slope, the A parameter, is right here. It's at the 50-50 mark. That's where the A slope is. The others then vary in difficulty until we get to the item 1, that one right there, almost, the other blue one, yeah, that one. That one is the hardest item. So look at what happens for anybody whose theta is above 0. Basically, anywhere from 0 up to positive infinity, they're almost guaranteed to be able to do all of these items. The consequence of that omission of items on the positive side lends itself to a test information curve that looks like this. Is that funny? It's kind of sad, isn't it? It could be sad. So test information is the sum of all the individual item informations, which is the loading squared times the probability of a 1 at that value of theta times the probability of a 0 at that value of theta. So if we can make a curve for each item, add up those curves, and that's test information or total information. So the y-axis is in this weird metric of information where more is better, but regular people aren't going to know what to do with this. So you can convert this y-axis of information into a reliability metric that ranges from 0 to 1 as information divided by information plus 1. And so that is the bottom picture here that I made. M+ in computing information adds a constant of 1 to every value. It says it's an acknowledgement of the prior that's on theta, that it's supposed to be from a normal distribution, which seems a bit sketchy, but that's why it asymptotes at reliability of 0.5, because the lowest that information can be is 1. So in terms of deciding whether or not I have a reliable measure, what would you say? Is this 7-item instrument sufficiently reliable to be used in research or in life?
I would say that it depends on your purposes, because, for example, if you are interested in people who have not many problems with those kind of tasks, so I would say that this is useful. But if you are interested in another kind of population or people, so you will need maybe a different set of items.
Yeah, so if my goal, so if I'm like, the administrator of a nursing home, and I want to have a questionnaire to give people like who are potentially interested in moving to my nursing home, and they're not sure what level of assisted care they might need, because nursing home communities start out with just you get your own apartment, and then you might move up to where you have an apartment that gets monitored, where somebody stops by, all the way up to what would be essentially a hospital room. Like if I'm that administrator and I want to place somebody, this might do a good enough job. Because if you're able to do these things, I don't need to help you, and you can go live in your own apartment. But if you're somebody who has difficulty completing some of these tasks, then this would help me to try to figure out just where you are on this continuum and what you'd be capable of doing. So the model directly predicts for any given level of theta what your probability of being able to do each task is. And you can trace that out to say, well, I only want people to live by themselves if they have at least a 75% probability of being able to bathe themselves, or like whatever cutoff that you decide is what you want to do, but you have information about those people. Now, if that wasn't good enough, if I were giving this scale for research purposes and I wanted to measure functioning of older adults as a broader concept, including people who are really high functioning. How do I fix this? Can I do it with the items that I have? More items. More items or more of a certain kind of item? Because classical test theory would be like, just add some more items, it's fine. It's not fine. We need more higher items. So I need to ask these people, like, can you do Pilates? Can you train for a marathon? Can you organize a conference and then go lead it? Like, I don't know what the high level of difficulty things would be. But that's what we would need to make this better. Not just more items, but more items on the high side that can take this curve and try to keep it up higher. So the fact that we have this range of what I would call reliability and what others would call a converted piece of test information, this is why I think omega is a mistake. Because coming up with one number that describes just reliability across the board ignores the fact that you have no information after theta of 0 with which to measure people on this trait. Okay. How are we doing? Are we hanging in there? In week 9? Whatever this is? Do our brains hurt? Yes, mine hurts. My head hurts from the headphones and then my brain is like spinning trying to say these things. Yes, I feel you. So I've had questions from several of you about theta having a normal distribution, right? Do you think that these thetas are going to have a normal distribution? No. Here's my theta distribution. Does that look normal? Not even close. I have a giant pile of people here. These are all the people who said, I can do all of this. I have no idea how high they are because my scale doesn't measure them. So the idea of theta being normal is an assumption that we would use to create predicted thetas for people, but it's not going to change the information that you have in your model. There is no way that I can take people who all have the same score, they got all the items right, and stretch them out somehow. That's like the definition of a ceiling effect. It would show up if I just added these items together. It shows up when I try to do the fancy thing and estimate theta. I also appear to have a bit of a floor effect. So there's a few people over here, there's a little pile over here, where maybe they can't do any of it. And so I don't know truly how low they are. I would need to come up with even easier items to be able to assess where they stand on the low end of the theta continuum. Folks who've been through IRT classes, do you think that I should try to fit a 3PL to these data? Would that be a reasonable thing to do?
Probably not, because there's no guessing involved.
Yeah. There might be lying involved or pretending involved, but the C parameter is not going to take that. So yeah, this isn't a multiple choice thing. This isn't something where the probability of doing it depends on some other feature of how you've worded the question. So C probably wouldn't help you, and neither would D. This little box in here, one little piece, this is a summary of the factor scores. So the way that I got this picture and the way that I got this box was to ask for factor scores to be estimated. They are known as EAP estimates of the latent trait expected a posteriori. It's a combination of using maximum likelihood for estimation with the assumption of a normal distribution as a prior. So it's a little bit of Bayes. In other contexts, these are actually called empirical Bayes estimates. In multi-level modeling, that's what they'd be called. And they do have a mean of 0, at least to a few decimal places, but they don't have the variance they're supposed to. So according to the model, I set the theta variance at 1, if I output their best guess as to what each person's factor score would be, it's only a variance of 0.74. So this is why we don't want to use factor scores if we don't have to. The more items you have, the more information you have, the less of a problem this is. But for certainly 7 items, the factor scores are going to be pushed to the mean. The extreme values are going to be reined in, creating less variability than what they're supposed to be. The term for that is shrinkage. The other part of it, why you don't want to use factor scores unless you absolutely have to, is that we're ignoring differences in what the standard error would be around these factor scores. So each person not only has a factor score that represents the middle of their hypothetical distribution, but they've got the rest of their distribution around it. And in these models, how wide that distribution is around the factor score depends on how much information you have. So the people who are part of this pile should have a huge standard error because we don't know how high they are. People in the middle should have smaller standard errors. And information, the reciprocal of that, forms the standard error. So it's the square root of information is standard error in the reciprocal. So it's giving us the mean standard error for each person, but there's going to be much variability around that based on where their theta is. Yeah. Okay. Yeah. What does factor score mean in here? What does factor score mean, or what does the factor score mean?
I don't know what is factor score here. What does factor mean?
So in this context, the latent trait that we're trying to measure is one's capacity to live independently. So that would form a mixture to some extent of physical capabilities, but also mental acuity to be able to, do things like pay your bills or be able to go shopping and, remember to bring enough money, but also be able to walk around the store. So it's the scale this is from is known as the instrumental activities of daily living, and it's used as a screener for older adults who might need assistance getting through their daily lives. So the theta in this case is that specifically, but theta, factor score, latent trait, latent variable, latent construct, true score, all of those words mean that same idea of the latent thing that we can't measure directly, so we ask questions about it and try to measure it indirectly through item responses. Does that help?
Yes, I know what's the factor score mean, but you just says in this case, it's we shouldn't use a factor score, but what does that mean?
So it means that we should not take a data set of estimated factor scores that I use to make this histogram, for instance, and that these summary statistics are trying to describe. I should not take those factor scores and treat them as if they're observed variables in another analysis. That's what I should not do. Because each of them has a different amount of error associated with it, and if you just take your factor score and pretend that it's an observed variable, you are saying there's no error. And it's an even bigger problem because error is non-constant in this case. So what you would do instead is the reason you're in this class. You would fit a structural equation model to look at how this latent trait predicts other things, is a predictor of other things, is an outcome of other things. Whatever purpose you had in measuring these people, you can keep it in the latent space and not have to worry about the consequences of treating factor scores as if they're real measured variables, because they're not. Yeah, that's why. And that's one of the reasons why I'm emphasizing M+, is because you could have fit this same set of models, these 1PL and 2PL models, using full information maximum likelihood, or marginal maximum likelihood as it is called. You could have fit these using the MERT package in R. You could fit these using PROC IRT in SAS. Stata has IRT packages, like everyone on the planet has an IRT package nowadays. But those packages don't then allow you to add on a structural model that would allow you to look at the relations among your traits. The whole goal of the package is to get your item parameters and then potentially use those to get person parameters, but you're stuck there. Whereas in M+, you can take this as the baseline measurement model and then go and do stuff in the model directly without having to output factor scores. Does that help? Maybe? Am I still here? I'm still here. We're barely not here. Yes, thank you. I know there's a lag. I made a plot of the items and where they are on their difficulty values. So they're in order of the original items. So 1 is the most difficult, 7 is the least difficult. And the y-axis of this plot is in difficulty, meaning how much theta do you need to do this with a 50% probability. That to me is much, much easier than thinking about the thresholds, which tell you for an average person, what is the logit of the probability of a 0, and then the same information from the thresholds in a probability metric for an average person, what is the probability they're going to be able to do each of these tasks. And it's near 1 for bed making and telephone, which are the easiest. All right, there, we made it through all the logits. Hooray. So, any other questions before we turn our brains off for a few hours and call it a day? Question, do you mean that IRT cannot capture the relation between factors but only capture the item factor pattern? I mean that IRT software cannot capture the relation between factors if it is expressed as anything other than a covariance. So it's a limitation of the structural model, what you can do with your factors. That's the problem with IRT software. You can allow multiple factors in the model, like if you have a 2-factor model or a 3-factor model, and you can allow those factors to be correlated. But then you can't say, hey, how does activities of daily living predict, working memory or, presence of dementia or any other kind of answer that relates to how the factors predict stuff? That's not possible in the package. So that's where you'd have to get some skill in programming and do it in Stan or something to where you have complete flexibility of what's all in the model, or you can use an SEM package that has link functions such as M+. But IRT software, as a general principle, does not have a structural model part built into it. And that's why I'm not even showing MERT, is because it's not going to allow us to do anything else beyond just get the item parameters. You are welcome. All right, then what we have to talk about next time, not ordinal yet, but we get to talk about estimation. And then I will show you the same 2 models under limited information estimation instead, where the difference is the scale, the difference is assumptions of missing data, but it's going to be a lot easier to build on using limited information than full. So that's where we're headed next week. I will let you know when new handouts are ready for probably Thursday would be my guess as to when we might start ordinal, but not until then. So in the meantime, homework 3 on your own data. Let me know if you need help troubleshooting M+, or if you're not sure what to do with your models. I'm going to hang out here on Zoom if anyone wants to talk to me. I know at least one person said they do. Otherwise, let me know if I can help you. Office hours are on Monday afternoon for last minute questions. All right. All right. Thank you for being here. Have good weekends.